Let's go and look at, again, I think last class I told you guys that I wish I had put some of those due dates sooner, but they aren't. So,
I can't hear you.
okay,
I don't know if it's just me.
let me put on the headset. Hopefully that's better, and I'll try to talk louder and slowly and clearer. Um, so uh, please don't leave those homeworks go until the day before, because you know, that's we're going to be moving on rather quickly. This homework 2.8 is on what we did last class with distance and circles. We're actually going to start looking at what's on homework 3.1 today. Everybody realizes that Wednesday is Veterans Day. There are no classes. And what I forgot to put in here is that there's a linear quiz, which will be due on the 12th at 11:59 p.m. And it's going to be on the equations of lines. So you need to know your linear formulas, your slope formula, and all of that. You must submit work in Blackboard, but the quiz itself is in my math lab. So you look at the questions in my math lab, but again, I think I've said before, the grade in my math lab does not count. The only grades that count in my math lab are your homework grades, and that homework average will be brought over to Blackboard. The way the quiz and test grades get brought into Blackboard is through the drop boxes there for your work. And so the grade that counts in every quiz is the grade for your work in Blackboard, not the grade in my labs. Somebody pointed out to me, I don't think in your class, but in one of the other classes, that because of the way that is, that you can't see your quizzes and tests again in my labs. And I apologize for that. It's because they're not weighted. And so I think I'm going to, what I did for the other classes was I made them worth 1% of your grade in my labs, which really doesn't affect your grade that much. It allows you to see them. I know I did that for my contemporary math classes. I'll double check and make sure that that's done for your class so that you can go back and look at it. Because if the grade does not count, it does not let you go back and look at it. So I will make that adjustment. Before we get started from where we left off last class, does anybody have any quizzes on anything? Questions on, oh Lord, quizzes. Any questions on anything? I did get somebody in the other section email me a question about one of the homework problems. And so in the off chance that that is a concern for any of you folks, I'd like to just look at that real quick. Because when we were looking at
You're breaking up really, really, really bad.
Is that any better?
That sounded okay.
Okay. So let's look at in the homework, I believe it was homework 2.8. Someone was asking me about question 2. And the reason for the concern I'm trying to close things in hopes of helping the audio. The reason for their concern, I believe, was the fact that all of the examples that we had done in class mostly involved whole numbers, and this problem didn't, so I'd like to just look at it. It asks for the distance between the points 5.5, 8.2, and negative 0.5, 5.2. And because it asks for distance, is everybody comfortable with the idea that we'll be using our distance formula? Even though those are whole numbers, we're going to just substitute them in the same way. The difference in the x values would be 5.5 minus negative 0.5. And the difference in the y's would be 8.2 minus 5.2. And so over here, minus a negative would become addition. So that's 6 squared plus this difference here would give me 3 squared. And then from there, it'll work as if we had started with whole numbers. So that's the square root of 36 plus 9, which is the square root of 45. And then they want it simplified. Here we'd have to use a radical. So that would be the square root of 9 times 5, or final answer would be 3 radical 5. And so if the numbers are fractions, if the numbers are decimals, even if the numbers involve radicals, when we substitute it into the distance formula, it works the same no matter what. Any questions on that? If not, does anybody want to look at anything else from any of the homework? If not, I'm going to close my labs and open the notes. And I'd like to pick up from where we left off. And we were looking at circles. The general equation of a circle with center, a given point, HK, and radius, a given number R, was given by x minus h squared plus y minus k squared equals r squared. And by looking at the fact that that's just an application of the distance formula, hopefully helps you remember that formula better. But let's look at an example of the type of problem we finished with last class. Let's find the center and radius of the circle with the equation. And let's say we've got x squared plus y squared plus 16x minus 12y plus 19 equals 0. Does everybody remember that the way in which we know it's a circle is because both x and y are squared? And we can put it into a form where they have coefficients of +1. It's going to turn out that if both x and y are squared, as long as they have the exact same coefficients, it will be a circle. This semester in this course, they should both have coefficients of 1. But as I look at that, it's not that center radius form that we like. It's in general form. Help. Can anybody remind me of what we did to put that in center radius form? Anybody remember what we had to do first?
Put it in like the right order where the x's are together and then like the y's are together.
Okay, so x squared plus 16x plus y squared minus 12y. And what did we do with that constant term, that 19? Remember, we wanted to move it to the other side so that the constant was alone on one side. After we did that, we needed to come up with numbers to fill in those blanks. Can anybody explain to me what number would go here with the x's?
You would, wouldn't you divide 16 by 2 and then square that to
Beautiful.
get,
64,
and the same thing with the y value.
right. And remember that whatever I add to one side of my equation, I have to add to the
The
other.
other one.
So when I take negative 12 and divide it by 2 and square that, that would be 36. And so that gives me x squared plus 16x plus 64 plus y squared minus 12y plus 36 equals 81. That's still a mess. What should I do next? How can I rewrite this trinomial?
Oh, don't you, is it factor or is it complete the square?
We completed the square by adding. So now that's a perfect square trinomial. And so you're right, we're going to factor that. And if I were to factor,
Is it x plus 8 squared?
that would factor into x plus 8 times x plus 8. Or we made sure it was a perfect square, so it's going to be x plus 8 squared. How about the y's? What would that factor into? What would I be squaring?
Y minus 6 squared?
Beautiful, y minus 6 squared. And on the other side, I have my 81. Now we're in that center radius form, so we should be able to look at that equation and figure out what the center is and what the radius is. And again, hopefully you know, but the general form is x minus h squared plus y minus k squared equals r squared. And the center would be my hk. So if I have x plus 8, what am I subtracting from x?
Is it minus 8 and then 6?
Beautiful. The center is negative 8, 6. We're subtracting negative 8 from x. We're subtracting 6 from y. And then the radius is r. So if the radius squared is 81, what would you tell me the radius is?
9?
9. Beautiful. Great. Are you folks comfortable with these? Because I know that to this point, probably one of the more involved things we did with self-quadratics by completing the square. And to find the center and radius of a circle, we got to do that twice. Are you folks all right with that? Or do you want me to shut up and give you a minute to try one more on your own?
We can try another one.
All right. So I want you folks to please find the center and radius of x squared plus y squared plus 4x minus 2y minus 85 equals 0. Let me know you guys think you had it, and we'll go over.
I think I have it.
Okay. How about the rest of you? Is anybody getting the center to be negative 2, 1, and the radius to be 3 radical 10?
Yep, that's what I got.
Do we need to add details for anybody, or are we comfortable? Are we good, or do you want me to fill in the details, folks?
Can you break down the radius? I got radical 85. Was I just supposed to simplify that further?
Well, we're going to add 85 to both sides. Gives
Oh,
us
I forgot to add the
right,
on
5.
each side.
Y squared minus 2y equals 85. Here, when I take half of 4 and square it, I'm adding 4. When I take half of negative 2 and square it, I'm adding 1. So I have to add that to both sides. So that gives me x plus 2 quantity squared plus y minus 1 quantity squared equals 90. And when I take the square root of 90, that's 9 times 10. So that gives me 3 radical 10.
Yeah, I forgot to add the 4 and the 1 to each side.
Okay, just be careful. And again, if you were doing something like this in my lab, I wouldn't give you any credit because it was wrong. But if I could see that that was the careless mistake that you made, you would probably get at least 3/4 of the question value. All right?
Yep, thank you.
Okay, so if we're good with these, and somebody just came in, who did I just let in? Was it Ty?
Yeah.
Okay, I'm gonna stop for a second and make note of the fact that you came in late. And then let's go on then, and let's look at next section is the graph of a quadratic function. And so a quadratic function is a function of the form. It's a function f of x equals its quadratic ax squared plus bx plus c. Again, can anybody refresh me? What does f of x mean?
It equals y, right?
Yep. So this is just y equals ax squared plus bx plus c. Again, it's second degree. And if it's written this way, it's a function. In order to be second degree, a cannot equal 0. Is everybody all right? If a were 0, then we would just have our line. And b and c are real numbers. Graph of a quadratic function is, I'm gonna stop sharing for just a second, guys. And go through and, because I'm hearing a little bit of background music. Not that I don't like your choice in music, but it's a little distracting. So the graph of a quadratic function is a parabola. And the parabola is a curve that looks something like this. I think we've done a couple of graphs of that form. And one approach, we're going to look at a couple of different approaches to parabolas. One approach to a parabola is to look at it as a transformation of a general parabola. And so we're going to take a minute and look at our rules for transformations. And compare the transformation to the original parabola. Can I turn the page and not lose anybody?
No, can you hold on a second? I'm almost done though. I have like 2 things to write, but
Okay. Ready?
no. Okay.
Okay, I'm going to do a lot of graphing and a lot of writing on this next screen. So we're going to consider our basic parabola to be f of x equals x squared or y equals x squared. And so I'm going to make a table of values for that off to the side here. And for x values, I'm going to take the integers from 2 to -2 inclusive. And so when x is 2, y would be 2 squared, which is 4. When x is 1, y would be 1 squared, which is 1. When x is 0, y would be 0 squared, which is 0. Now with the next ones, you have to be careful. If you substitute in a negative number, you want to put parentheses around it, because when x is -1, -1 squared, when I square a negative, becomes +1. And next, when x is -2, when I square a negative times a negative is also positive. Again, if you don't put those parentheses in there and you're using your calculator to get these values, you might get something different. Watch your signs. I'm going to graph this over here. I'm going to label my x-axis and my y-axis. I'm going to add a lot more pictures to this graph. So I am going to label my axes a little bit beyond what we might need. So I've got when x is 2, y is 4. When x is 1, y is 1. At 0, it's 0. When x is -1, y is +1. When x is -2, y is +4. And I get this general shape. And so that's my y equals x squared. Does everybody notice that outside of the fact that I can't draw real well, it should be a mirror image. And so it's got this axis of symmetry, this line that I could fold over, and it would be my y-axis, or the line x equals 0. It's got what we refer to as a vertex or a turning point. Where it goes from decreasing to increase, and it's 0, 0. And as I look at it, does it make sense that I'm going to describe this as opening upward? On that same axis, I'd like to look at a couple others. Let me play with colors here. Next, let's sketch y equals x squared plus 2. And so I'm going to use that same domain for my table, going from 2 to -2 inclusive. And so when x is 2, y would be 2 squared plus 2. 4 plus 2 is 6. When x is 1, y would be 1 squared plus 2, or 1 plus 2 is 3. When x is 0, y would be 0 squared plus 2, which would be 2. at -1. -1 squared is 1, plus 2 is 3. And at -2, -2 squared is 4, plus 2 is 6. Is everybody comfortable with my arithmetic there? And so if I go and sketch those points, at 2, it's 6. At 1, it's 3. At 0, it's 2. At -1, it's 3. At -2, it's 6. And I get this parabola. So this is y equals x squared plus 2. Again, outside of my total lack of artistic ability, doesn't it look like it kind of has the same shape as the other one? It still opens up. As I look at it, it still has that same axis of symmetry. The line x equals 0. But the turning point is different. The vertex, let's call it vertex and not turning point, I apologize. This time is the point 0, 2. And if I compare that blue parabola to that black parabola, they have the same shape. The only thing we did was we took it and we shifted it up. And we moved it up to when we added 2 at the back. So I'm going to keep going back and back to this page, but I'd like to add a little bit of a summary of what we're doing on the next page, looking at transformations. On y equals f of x. And where I had that y equals f of x, that was my first parabola. And when I added a value a at the end, didn't I shift it up a units? I moved it up 2. So if adding a number after the function moves it up 2, what do you think it'll do if I subtract a number from each value? Instead of adding 2, it went up 2. If I would have subtracted 2, could everybody picture that this would shift down? Whatever number a is, units. Does that make sense?
Yeah, that makes sense.
Okay, then let's go back. I'm going to do the next one in green. This time I want to sketch y equals, I'm going to add 2, but this time I'm going to add 2 inside the parentheses. So I'm going to add 2 to x before I square it. My new equation is x plus 2 quantity squared. I'm looking for the corresponding y values. And again, let's stick with 2, 1, 0, -1, -2 for our x values. And so when x is 2, y would be 2 plus 2 quantity squared. 2 plus 2 is 4, squared would be 16. When x is 1, y would be 1 plus 2 quantity squared. 1 plus 2 is 3 squared is 9. When x is 0, y would be 0 plus 2 squared, which is 4. When x is negative 1, y would be negative 1 plus 2 quantity squared, which is 1. When x is negative 2, it would be negative plus 2 quantity squared, which is 0. And I'm going to add one more. When x is negative 3, y would be negative 3 plus 2 quantity squared. Negative 1 squared is 1. So I have to apologize. My original axes I made a little short. Let's see what we can do in terms of plotting some of these points. When x is negative 3, y is 1. When x is negative 2, y is 0. When x is negative 1, y is 1. When x is 0, y is 4. When x is 1, y is 9. That's going to be up here somewhere. Beyond that, I think I'd be off the page. And so I'm going to connect the dots. And with my arrowheads, do you guys see that that green parabola that we just drew has the same shape as the black one we started with? But what's different is we didn't shift it up or down, but rather we shifted it to the left, didn't we? And so by adding a number to the x, I shifted it to the left. Does it make sense that instead if I subtract it, I would shift to the right? So going back to our summary page, y equals f of, if I add to the x value before I substitute it into the function, it's shift left. And instead, if I were to subtract from x, it would be a shift right. And I know that one's a little counterintuitive to people. People would think that adding positive, it would move the other way. But please notice when we did our substitution, when I added, it moved it to the left. And so if I were to subtract it, it would move it to the right. So going back, this new one still opens up. But this one, the axis of symmetry, well, this one, if I were to put that dotted line down the middle, it's no longer my y-axis, but rather it's the line x equals -2. And if I look for, with this one, the vertex or the turning point, it has an x value of -2 and a y value of 0. And I know I've cluttered up the picture a lot. I'd like to try to fit one more on there. Before I start that next one, is everybody all right with what we've done so far?
Yeah, I'm good.
Then the next one that we're going to look at, I guess we'll do this one in red. This time, let's sketch y equals the negative of x squared. And so let's use those same x values from 2 to -2. Let's substitute them into y equals the negative of x squared to find y values. And so the negative of 2 squared would be -4. The negative of 1 squared would be -1. The negative of 0 squared would be 0. The negative of -1 squared, but when I square -1, I get +1, and then I'm negating it. So I'm back at -1. And when I look at the negative of -2 squared, would give me -4. And so plotting those points, at 2, it's -4. At 1, it's -1. At 0, it's 0. At -1, it's -1. And at -2, it's -4. And if I look at that red parabola compared to my original black one, do you see how I've flipped it? I've turned it upside down. And so, everybody all right if I go back to that other page? If I have y equals the negative of f of x, we flip it over the x-axis. It's a mirror image. If I could only spell reflect. And I have to go back because I forgot to make note of a couple of things with respect to that graph. This was our first one that opens down. The axis with this one, because I'm not shifting it left or right, is still that y-axis, x equals 0. And the vertex of this one, because I'm not moving it up or down either, is still the origin. Now, there's one more transformation that I could look at, but at this stage of the game, I think our picture's a little bit too sloppy. But if I were to, instead of adding 2 outside or adding 2 inside, or multiplying by -1, if I were to multiply those function values by +2, 0 would stay where it is, 1 would go to 2, 4 would go to 8, and what it would do is it would stretch it, it would elongate it, it would make it taller and skinnier. And so going back to that page where we're summarizing our transformations, we'll say that if I have y equals some constant a times f of x, it will be a stretch. If a is greater than 1, and it'll be a shrink if a is a number between 0 and 1. If I were to take half the values, having the y values for the same x values would give me kind of a shorter parabola. And so, putting all of these pieces together, we talk about a parabola in vertex form. And it would be my f of x equals a times x minus h squared plus k, or my y equals a times x minus h squared plus k. And when an equation of a parabola is in that form, first of all, if a is positive, if it's positive, it opens up. If a is negative, it opens down. And so I think of it as if the coefficient is positive, it's a happy parabola. And if a is negative, it's a sad parabola. When I look at this, the vertex, well, over here, if I have, and if I'm subtracting h from x, I'm moving it h over to the right. If I'm adding k at the end, I'm moving it up k. So the vertex will be the point hk. The axis of symmetry, if we look at each of the parabolas that we graphed on the preceding page, the axis of symmetry went through the vertex. So it will be a line of the form x equals h. And so if we can find the vertex, find the axis of symmetry, and determine which direction our parabola goes in, that's the lion's share of what we need to graph it, because we know the shape of a parabola. What we need then is a couple of additional points. And for our additional points, we're going to use our intercepts. And again, for the y-intercept, we'll substitute x equals 0. And for the x-intercept, we'll substitute y equals 0. So a lot of time developing it. Let's look and see in practice what that means. Does everybody have all of this down? Or do you need for me to wait a minute, guys?
I need I need some time to write this down.
Okay, I'll wait. Let me know when you're ready.
Okay, I'm done. Thank you.
Okay, everybody else done too?
I'm good.
If so, let's go ahead.
Oh no, I was just saying that I'm good and I wrote it down.
Good, thank you. Let's sketch f of x equals -2 times parentheses x plus 3 quantity squared plus 8. And now this is already in that vertex form. And so we're not going to worry about simplifying that equation at all. We're going to leave it and compare it to our f of x equals a times x minus h squared plus k. And in that comparison, the first thing we're going to do is we're going to find the direction. And to find the direction, we're going to look at a, which is -2. Because it's negative, we know that this is going to be flipped upside down, and so it's going to open downward. Next thing we're going to do is we're going to find our vertex. And our vertex is going to be the point HK. H is what we're subtracting from x. So we've got to change that to a -3 because x plus 3 would be x minus a negative. K is the value that's being added at the end. So K is 8. And so our vertex is the point -3, 8. Then we need our axis of symmetry, our symmetry line. Our axis of symmetry is the line x equals h. So it would be x equals -3. So in order to graph this, we know that our turning point is at -3, 8. We know that from here, our parabola is going to be opening downward. And we know our line of symmetry would be along x equals -3. And so we get a good idea of what this parabola is going to look like by just looking at the equation and not doing any additional work. However, we do need more than that. So we're going to find our intercepts. And hopefully shrinking the page doesn't make it. Can you guys still read it if I shrink the page so that we can fit it all on one screen?
Yeah.
For my y-intercept, we're going to let x equal 0. F of 0 is -2 times 0 plus 3 quantity squared plus 8. So let's see, what would that be? That would be 3 squared is 9 times -2 is -18 plus 8 would be -10. And so
Hello? Did you guys wait?
Yeah, we're still here.
Yeah, we're still here.
Okay, I plugged this thing in this morning, but somehow the power cord wasn't, I don't know what's going on. It's saying that my battery is dead, even though it's plugged in. But this happened with one of my other classes on Friday. And so if you give me a minute, it should come back. What time do we have, folks? What o'clock is it? Let's, because we're a little bit ahead of the game, I think let's call it a day because it's gonna take a while for me to get back in. And we'll pick up from here next class. Is that all right?
Yeah, that's fine.
Okay, have a good Veterans Day. I'm sorry for the technical difficulties and we'll hopefully be able to make up for lost time on Friday. Okay?
All right.
All right, have a good one.
Have a
You
good
too.
day.
If there's anybody who came in after I took attendance, let me know. Bye-bye. Aaron, I gotcha. All right, we'll see you guys next time. Bye-bye.